Applications of divide and conquer. The first one we can say finding maximum and minimum. Next we can say binary search. Third we can say power of an element. Next is merge sort. The next is quick sort, and the next is Strassen matrix multiplication, and next is maximum sub array sum. The next is selection procedure. So these are the applications of divide and conquer. So first we start with finding maximum and minimum. So first start with this. Suppose we have n array element, so we can say input is an array of n element, and an array of n elements, and output will be the max and minimum in the given array of n element. So suppose we have input like this, element like this. So this is the index number, we can simply assume, for understanding purpose, that's it, nothing else. So what will the output? The max will be 31 and min will be 1. But how to find out using divide and conquer? Before going ahead divide and conquer, first we start with without divide and conquer, and we find out simply by comparison purpose. So how we are going to do that? Max, we can simply say first we cross check 10, then compare it to the all element from second. First we are taking first element, that is 10, then we are comparing it to all from second element. We'll compare this element to all element from second element. So if there are 9 elements total, so one is this, so total 8 comparison will occur. Total 9 and one is this, so 8 comparison will occur. So we can simply say n minus 1, n is equals to 9, so 8 comparison will occur, so n minus 1. Like that we will do for second element, then we will compare, then third element we will compare, like that we will do. So it will go like that. And for same, we can simply say for minimum finding we will do the same, we will follow same way comparison. So again n minus 1 comparison will occur, so total we can say 2 n minus 1 comparison occur, and for n minus 1 for maximum and n minus 1 for minimum, so total 2 n minus 1 comparison will occur. So suppose if we write this in the programming form, then how we will write? Straight max min a n. So we are defining int max min I max, these are the variables we have taken, max, min, and I is for which place we are comparing for comparison purpose. So max is equals to min is equals to array of 1. It means there is only one element. But for I is equals to 2, I less than n, I plus plus, then more than one element, then initially we are supposing max is equals to min is equals to first element. So we will start comparison from 2 as we have did here. First we take supposing max is first element, and again we are supposing minimum is first element. So that's why we have taken max is equals to min is equals to array of 1. We are supposing it, and we are starting comparison from the second element. So we are writing I is equals to 2, I less than n, I plus plus. It will go up to n. So if max is less than array of I, which we are supposing, then we are giving array of y to the max. If max is less than this element, then we will assign this value to the max. Else, if minimum is greater than array of I, then we are assigning this value to the minimum. This way it will work. So, and after that it will return max min and closing of the min function. So closing of the min function, this is closing for the for loop. So we can simply say the complexity of the best case complexity will be 1 into n minus 1. It means we are not going into the else condition, only if condition we are doing only one comparison. So we can simply say omega n best case. And what will be the worst case? Worst case, we are going in both if and else both loops. So total comparison 2 n minus 1. So this will be the worst case. So we can simply say big O n. And the average case, half will go best case, half will go worst case. So we can simply say n minus 1 by 2 plus 2 n minus 1 by 2. So it will be 1.5 n minus 1. So we can say theta n. So average case complexity. And if we are talking about the space complexity, so total number of elements, total we have because n element, total have n element, so we are taking 2n byte because all are of integer type, so 2n, and 3 local variable we have max, min and I. So 3 into 2, 6 byte, because we are taking all the elements are integer type. That's why total element n, then 2n byte, and 3 local variables. So 3 into 2, that is 6 byte, because integer is having 2 byte. So we can simply say 2n is greater than 6. Obviously 2n is greater than 6, so we can simply say order of n. The space complexity will be order of n. So this is all about, initially we are talking about without, if we are using finding maximum minimum without divide and conquer. In the next lecture we will learn how we can do same thing with divide and conquer.